Hi gents, thank you for your questions that you've been sending me. This is 2015 and it is paper 2 and it's question 3. Better double check that is definitely right. Yeah, okay. So that's what we're dealing with. This is the homework that I sent you, and some of you just sent in a few questions just asking how to do bits and bobs. So here come the answers. We'll put them up for you here. The line L1 is perpendicular to AB. Find the value of t. So whenever you see perpendicular, first thing that you should be thinking about their slopes, since they're at right angles to each other, is that the slope of one line multiplied by the slope of the second line should give you -1. Okay, so the first thing I would do here is I would go and I would try and get what is the slope of this line here. We'll call it M1. So in this case, what you're looking to do is you're looking to get the slope, but only by the equation. So I've mentioned this in a couple of the videos that we've gone and done. And that is that whenever you have an equation, this is well worth memorizing. Ax plus by plus c equals 0. When it's written like that, the slope is -a over b. So in this case, the slope is -a, that's -3 over b, which is -4. So we actually have that slope 1 is equal to just 3/4. That's a negative divided by negatives. That's 3/4 in there. Okay, we now need to get slope 2. So that second slope, which is going to be of AB, we can get it using the formula. The formula in this case is m for slope is equal to y2 minus y1 over x2 minus x1. So we label these x1, y1, x2, y2. So it's going to be, let's see, y2 is t minus y1, so that's minus a -1, that's +1, over x2, which is 7, minus x1, that's -4. So we end up getting t plus 1 over 3. Now remember what we said, if they're perpendicular, slope 2, they should multiply together to give -1. So I don't know, will I quite have enough space in the middle? Sure, I'll do my best to do it. So what are we saying? We're saying m1 times m2 giving us -1. So that's 3/4 times t plus 1 over 3 equaling -1. So that is top by top. Now remember, it's 3 by all of that thing. So that's 3t plus 3. The bottom's 12. And it's equal to, sorry, -1 is what I meant to write there. Multiply both sides by 12. We end up getting that 3t plus 3 is equal to -12. We get that 3t, subtract 3 from both sides. 3t is equal to -15. And there we have it. There's our answer. T is equal to -5. Okay. And if we do place it in, it's worth just a quick double check. Did we do anything silly with the algebra? If you place in -5 plus 1, we get -4 over 3 for this slope, and the other slope is 3 over 4. That's the other way that you know it. It's upside down and the overall sign reversed, as in 4/3. It's -4/3 where it's positive 3/4. That's what I mean by that. Okay, find in terms of k the distance between a point and line 1. Okay, so in this case they are giving you a line. The line is 3x minus 4y minus 12 equals 0. And they're giving you a point, which is 10k. When they say the distance between a point and a line, you know, if you've got a line and a point, what's the distance? Well, it could be that distance, it could be that distance. They're, of course, talking about at right angles. Okay? So they're asking what's the perpendicular distance between those 2 points, but they don't quite express it so clearly. So there is a formula. It's in the tables book. We've been using it. It's the absolute value of ax1 plus by1 plus c all over the square root of a squared plus b squared. Okay, this is our x1, that's our y1, that's a, that's b, that's c. And we're just going to trot it into that formula there. Did I want to say anything about it? Yeah, it says in terms of k, people get very scared about that. Just means that your answer should have a k in it, that's all. So we have d is equal to the absolute value of a Do this real slowly because it's so easy to make a mistake here. So it's a times x1, so that's 3 by 10, plus b, which is minus 4, by y1, which is k, there's our k coming into the action, plus c, c is minus 12, so we're adding on a minus 12, and it's all over the square root of a squared, that's 3 squared, plus, now minus 4 squared, you can just write down 4 squared, since if it's going to be squared, it's going to be positive, but it's supposed to be absolutely technically correct, we'll write down that. So the distance is equal to the absolute value of 30 minus 4k minus 12 all over, and it's the square root of, I suppose we'll do it slowly, 9 plus 16. Okay, you should never get a negative down there at all. Both things are being squared, so don't make any sort of silly mistake with it. Okay, the distance is equal to, well, 30 minus 12 is equal to 18 the last I checked. So 18 minus 4k is the absolute value of 18 minus 4k all over. That's the square root of 25. So that's just going to be 5. Okay, that's all. They just said find the distance, but get it in terms of k. So we have it there in terms of k. It says, now this is I think where a lot of the questions came in. It says 10k is on a bisector. Now I have a feeling that the B part there is going to be important. Is on a bisector of the angles between the lines L1 and some other line here. Okay, so let's think about what does this thing mean. Okay, we've got line 1. We've got line 2. So it's on a bisector of the angles. Now what does bisect mean? Bisect means to cut in half. So there are actually 2 bisectors that you would draw here. This is the line here which cuts those 2 other lines in half. Okay, that would be one of them. Oh crap, we've lost them. Okay, let's throw them back in. And the other one would be, for instance, that one there. Okay, that would be a perpendicular bisector. Presumably that's why it's saying that there's a couple of answers. Anyway, this is the bisector, and what it's saying is that 10k is on that line. Okay, 10k is on that line there. That's really horribly drawn. Let me try that again. Okay, such that, that's what a bisector is, such that it cuts from there to there. So there's 10k, it lives on that one. Now remember what we got the last time, what we just found is that the distance, this is tricky, that the perpendicular distance between that point and the line there is equal to the absolute value of 18 minus 4k over 5. We just got that. Now, if it bisects it, if that angle truly is that angle, then this perpendicular distance here, well, what are we dealing with? We're dealing with this angle being the same as that angle. Okay, those 2 thetas there. We're dealing with 2 right angles, and we're dealing with this side being the same. So what we have here is that that triangle, that one there, must be congruent or perfectly the same as that triangle there. Okay, and it just means as well that the distance must also be 18 minus 4k over 5. It's got to be the same thing. So actually what we want to do here is in order to find the possible values of k, I suspect what we'll need to do is we will need to go and I'll have to actually think about this now for a second. I think what we'll have to do is we'll have to go and get the same thing just made out in a different way. Yeah, that's exactly it. So what do we have? We've got 10k and we have 5x plus 12y minus 20 equals 0. So this is our x1, our y1, our a, our b, our c. So we'll say the distance is equal to the absolute value of ax1 plus by1 plus c. And it's over the square root of a squared plus b squared. So that distance, we actually know what that thing is already. We know that it's 18 minus 4k over 5. And it's also equal to, using our new piece of information over here, it's also equal to the absolute value of a, which is 5, excuse me, times x1, which is 10, plus b, which is 12, times y1, which is k, plus c, so we're adding on a minus 20, and it's all over the square root of 5 squared plus 12 squared. You should actually memorize that, that particular one off by heart. Okay, so what do we have? We've the absolute value of 18 minus 4k, that clear, over 5 is equal to the absolute value of, I'm going to kind of skip ahead here. You can see that it's going to be 5 by 10, that's 50, minus the 20 that's over there. So 50 minus 20, we're looking at here 30 plus 12k's. And down on the bottom here, that's going to be 25 plus 144, that's 169, square root of 169, everybody knows is 13, famously, no doubt. So that is what we have there. Okay. So there's a couple of ways, I guess, for us to proceed here as we go along, if we want. So what we can say is we can say here. I'm just trying to think of like the nicest way just to present this out for you. So 13 times 18 minus 4k. Absolute value of that is equal to 5 times 30 plus 12k. What I did there was I multiplied both sides by 5 and by 13 at the same time. Okay, and we've ended up with that. So as you know, with the absolute value here, you've got a few options, I suppose, as to how you go about it. What you could do is you could square both sides. Okay, you could square both sides. I don't recommend it. It's going to create an awful quadratic, and I'm not inclined to go and solve it. What you can say is that 13 times 18 minus 4k is equal to 5 times 30 plus 12k. Okay, so you can take one example there, and you can take another example, and it doesn't matter which one you pick, you'll end up with the same thing. Is equal to 5 times, and you just take the negative, the opposite of this, so minus 30 minus 12k. The reason for that is this. If I just say something very simple here, like the absolute value of a is equal to the absolute value of, I don't know, we'll say minus 7 or something like that. Okay, so there are two things here that a could be. Okay, a in this case could be 7, so you can simply say that equals that, and that's really what we've done here. We've just said that side equals that side, done. Okay, a could be 7 because the absolute value of 7 is equal to the absolute value of minus 7. They're both just equal to 7, so it is true. And also it's true to say that a is minus 7, and that's kind of what we've done over on this side. We've said that this thing is equal to minus the other thing. Okay, and it doesn't matter which side you pick. You could have said, well, minus a is equal to minus 7. Okay, that's the same as saying a is equal to 7. And you could say that minus a is equal to 7, which is again another way of saying that a is minus 7. So it doesn't matter whether you pick the left or the right to change the signs. You will get the right answer. I'm definitely going to need an L calculator here. 13 times 18 is 234. 26, 52. 52k is equal to 150 plus 60k. I shouldn't be trying to do too many things in my head because it just won't go well. I know from experience. So we get 84 here, and what do we get? We get 60 plus 52, 112 k's. I suppose I better just double check my figures, just that I haven't done anything asinine. That is 54, that is definitely 150, and that is 60. Yeah, so that looks all right to me. Divide both sides by 112, and we get that k is equal to 3/4. Nice. 234 minus 52k, that didn't change. This time it's minus 150, and it is minus 60k. So I think we'll bring the k's over to the left-hand side, we'll get 8 k's. And we'll bring minus 150 minus 234 to the right, so minus 384 there, divided by 8. k ends up being minus 48. So there you go. Yeah, they really didn't leave a lot of room there for you to fill all that stuff in. That's just a little, you know, cautionary tale of like, just watch out for that. You know, it's one of those things that that could catch you out. Okay, if k has to be positive, get the distance. Okay, so what they're telling us, we got two values for k here. We got that, and those would stand. But for part 2, it says if k has to be positive, so we have to say that k is 3/4. Okay, that's now given to us that must be the case. We can't take minus 48. What is the actual distance? Well, we knew all along that the distance is equal to the absolute value of 18 minus 4k's over 5. That was actually one of the things that we found out. I think it was, yeah, part B there. So that distance is equal to the absolute value of 18 minus 4 amounts of 3/4. Nice number there. We won't even need our calculator for this. So it's the absolute value of 18 minus 3 over 5. So our distance is equal to the absolute value of 15 divided by 5. The absolute value of 15 is just 15. And when you divide that by 5, you get 3. So there you go. You get 3 as your answer there. So that's like a fairly typical coordinate geometry question. Not the easiest in parts. Like, of course, you have to come up with a plan. I think the most difficult plan there is that C part, probably unsurprisingly. And you know what? A good diagram helps. And just taking your time, knowing what each of the terms mean. What's a bisector? Okay, a bisector of the angles between that. That just means you get the angle in between the two lines and you draw a line in between it such that it cuts it in half. Okay, simple as that. And then after that, it's about practicing your algebra. Okay, so really it's one of those things, if you weren't able to do it, I would strongly suggest that you go and just give that one a little try again. I'm just gonna pause here, suggest another video and just find one for you. Sorry, another question for you to try out. Okay, I have found a doozy of a question here, if you'll excuse the phrase. This one was tough. This one was mean. I think the A part and the B part are probably fine, but that C part is a tough one. And this one is actually, honestly, this one is worth memorizing. Okay, because you might want to try this one just before the leaving cert or something like that. Actually, you know what? I will share this one with the 6th years as well, because it's such a tricky question to try and work out on the fly. If this is the first time that you've seen it as your exam, then you're gonna have some difficulty, I think, just in finding it. So let me just bring that up onto OneNote. There you guys are. Okay. The line OR-S cuts the x-axis at the point OR and the y-axis at the point S 0, 10 as shown. The area of the triangle OR-OS, where O is the origin, is that. Okay, find the coordinates of OR. So in this case here, first bit, by the way, 5th years, stop the video, try all these questions. It's 2014, it's paper 2, it's question 5. Do try it yourself first of all, but here come the answers for everybody. Okay, you can just use the formula here. There's nothing tough about this here. You don't have to be clever about it. In some ways, we have the area of a triangle is half the base times the perpendicular height. So we know what the perpendicular height is from there to there. Let's do this one in green. We know that the perpendicular height from there all the way up to there is 10. Okay, we know that because it's 0, 10. We've moved left or right, nothing, but we've moved up 10. And we also are given the area. It's 125 over 3. The base is therefore the only thing that we don't know, because that's 10. So we have 125 over 3 is equal to 5b. And you can divide both sides by 5 here without a worry. So we just get 25 over 3 is equal to b. Just going to double check that I haven't done anything stupid, just so I don't ruin a video. Yeah, that's perfectly fine. Okay, so that's what b is, but that's not what the question is. What I've just found is what's that length there. Okay, so that will now allow us to figure out what or is. Well, don't muck up the signs. We've had to move left minus 25 over 3, and we're going up or down 0. So we have what or is. It's minus 25 over 3 and 0. It then says show that the point E, which is minus 5, 4, is on the line or S. So there's or S. Show that a point is on the line, you should be subbing it into the equation of a line. So to get the equation of a line, you need a point and you need a slope. Now don't take E as the point. The whole idea behind this is that we're going to show that that's on the line. So if you make a presumption that it's on the line and then sub it in, of course it will work. But that won't have shown that it's independently on the line or S. So you need to get what or S is first. So get a point on or S. 0, 10 looks just fine. Some nice numbers. And we need the slope. Let's get the slope. It is the rise over the run as you go left to right. So going from or to S, how much have we moved over when we go from or to S? So we've moved over, that's our run, we've moved over 25 over 3, because we've gone from minus 25 over 3 to 0. And how much have we moved up? We have moved up 10. So that's a little bit ugly. You might want to multiply top and bottom by 3. And we end up getting 30 over 25, which is 6 over 5. That's what our slope is. We can now get the equation of the line, x1, y1, so it's y minus y1 equals m times x minus x1. So it's y minus 10 is equal to 6/5 times x minus 0, so you can just say 6/5 x if you want. So y minus 10 is equal to 6/5 x. Multiply everything by 5. 5y minus 50 equals 6x. 0 equals 6x minus 5y plus 50. And the whole point was to show that minus 5, 4 was on it, so we're subbing it in. Minus 5 for x, 4 for y. 0 is equal to 6 times minus 5 times y, which is 4, and plus 50. So hopefully this works out. 0 is equal to minus 30, minus 20, plus 50. What do you know? 0 is equal to 0, and we say therefore, so it satisfies the equation is what you would say in mathematics. Therefore E, which is minus 5, 4, is on the line. Okay, so far so simple. They've sort of led us up an easy path then to this C part here, which is really just a nasty question, but one that they like to ask, and it's a real one to show that you really know your stuff as you go along. It says a second line, y equals mx plus c, where m and c are positive constants, pass through the point E. Okay, now remember m is our slope, so it's a positive slope because it says m is positive, and c is where it cuts the y-axis. It's the y-intercept. That's also positive. So we know stuff about it. So we can say it's got a positive slope, goes through E, and it cuts the y-axis in a positive place. So it looks something like that. Okay, that's the line that we're dealing with. That would have a positive slope, and it cuts there. Okay, and what it says about this thing here is it says that it tells us that it makes another area of the triangle here. So what do we know? We actually don't know very much about this line here. We know that E goes through it. Okay, that part we can say, or that E satisfies the equation. Just a reminder that E is -5, 4. Okay, so I'm gonna maybe like nudge you once or twice into what you think might be a good idea when it comes to it here. And remember what we're trying to find. We're trying to find out what is the equation of this line here. So maybe I'll just pause it for a second. You can have a little bit of a think about it. Okay, right. Hopefully you've paused the video there and had a little think. If not, look, here's the little nudge. Remember, to get the area, which is what it's all about, we're interested in what is the base and what's the perpendicular height. So is there a way for you to write down here what this base and perpendicular height are? And the way that you would get that is to find out what's this point there and what's this point here. Okay, remember, this is where it cuts the y-axis. So where something cuts the y-axis, you will hopefully remember, and I'd write it for my examiner. Where something cuts y-axis, that implies x is 0. So if you take y equals mx plus c, and you let x equal 0, y will be c. So that gives us the point 0, c. So we can fill that in, 0, c, right there. Fill it in with green. This point down here, this one's a little trickier, where it cuts the x-axis. That implies that y is 0. Okay. When y is 0, we again get y equals mx plus c. When y is 0, we get mx plus c is equal to 0. Remember, we're trying to find out what's x, so we get minus c is equal to mx, and x is equal to minus c over m. Okay, so this point is minus c over m, that's our x value, and our y value is 0. Right, that actually gives us enough information. Strangely enough, it gives us enough information, because we know that the area of a triangle is equal to half the base times the perpendicular height. Well, the base, what have we moved over again? We've gone from minus c over m all the way over to 0, so our base is actually c over m. And what is our height? Our height in this case is equal to c. We've gone up as high as c. And we know that this here is equal to the area of the triangle, which is 125 over 3. Okay, this is a good start. You can see here that there are two things that we don't know. There's a c and an m that we don't know. So again, this is a good chance now to try and figure out where is this other equation going to come from that's going to allow us solve it. So again, I'll just do a little pause. You can do a pause too and just think about it. Okay, well, what you should be thinking of is, what information have we used? So we've used up this information, that's fine. We've used up the y equals mx plus c to a certain extent. We were able to use that to generate our 0c and our other point, which we actually didn't formally write down here, minus c over m, 0. So the question is, what haven't we used? And there's a big thing here that we haven't used. We haven't used minus 5 for. So we have 125 over 3 is equal to top by top by top, c squared, bottom by bottom by bottom is 2m. Okay, I think we can leave it there because we'll see what use can we make of minus 5, 4. And this just tells you that's your x value, that's your y value, and you can sub it in directly into y equals mx plus c. So that is actually the easiest one to get. But sometimes the easiest one can be the hardest to see, it really can. So we know that that's 4 is equal to m times x, which is minus 5, plus c. So that just tells us that 4 minus 5m, 4 equals minus 5 plus 4m, and it also follows that 4 plus 5m is equal to c. And now we can go and plug that thing into our top equation there. So we have that 125 over 3 is equal to 4 plus 5m squared over 2m. So we now have that 125 over 3 is equal to, let's see if we can do this in our heads, 16 plus, what's that, 20, 40m's plus 25m squared. Hopefully you haven't gone all rusty on that and you actually remember that. Okay, so we've got multiply both sides by 2m and by 6, so we've 250 m's is equal to, okay, by 3, I think that's going to be, I don't want to risk at 48, is it? 3 by 16, sorry, the head's a bit frazzled, it is 48, thankfully, plus 120m plus 75m squared. So we get 0 is equal to, oh, such beautiful numbers. So that's minus 130m plus 48. It doesn't even look as if there's some sort of nice thing here. It might just be an idea, I think, just to chuck this one into the quadratic formula and go from there. Normally I'm a fan of not doing that, trying to work stuff out and go from there. But let's see. Can I remember how to get this thing to do? Maybe I can't. Yeah, I can't. Whatever. Okay, let's just throw it in there. We know that that's A, we know that that's B, we know that that's C. Yeah, I used to have a calculator that would just get it for me straight. But anyway, we'll just do the formula. X is equal to minus b plus or minus the square root of b squared minus 4ac all over 2a. So we get x is equal to 130 because it's minus a minus plus or minus the square root of 130 squared minus 4 times a, which is 75, times b, which is, 4ac, c, which is 48. All over 2a, that's 2 times 75. Yikes. So it's not really x equals, it's m equals in this case. I wonder, is this going to be a nice number or not? Right. Let's try it out. 130 plus the square root of 130 squared minus 4 times 75 times 48 all over 2 by 75, so 150. Nice number it came out, that's always a good sign. M equals 6/5, and hopefully I can just go up into our top line here, change out the 130 plus all that into 130 minus all that, and it'll also be a nice number. It's 8/15 after all of that. So that wasn't the worst. Please don't forget to get what C is. It does ask us to get what C is here. Find the value of M and the value of C. Okay, we need to be careful here. Because there's going to be, we've just got 2 values of M out. So we just need to be a little bit cautious as to which one is correct. Oh wait, hold on. Did we actually get what M was the last time? Yes, it was, and it was 6/5. There it is. Was 6/5 one of our answers? Yes. Excellent. So we knew that one already. This is the new one though, and that's the one that they're asking for. And we now need to go and get a relevant C. So just stick it in here, okay, to get C right there. So it's going to be 8/15 added to 4. So C is equal to 68/15. Okay, they are two tough coordinate geometry of the line questions. Hopefully you were able to do them. If not, go back over them. That's why the video is there, and use it correctly as you do it. What we'll do now is we'll do coordinate geometry of the circle. That'll be the last topic, I think, which we do for the year. Okay, gents, take care. All the best.